Good evening, everyone. It's my privilege to introduce Mr. Koti Reddy, an accomplished professional in civil engineering and construction technology. He is currently serving as the Territorial Services Manager at Ultratech Cement, where he oversees construction chemicals, adhesives, and ready-mix concrete. His expertise in building products has earned his recognized for the subject expert in this field. Mr. Reddy holds M.Tech in Structural Engineering from Chiral Engineering College and B.Tech in Civil Engineering from Pace Institute of Technology and Science. Further enhancing his professional acumen, he is pursuing an MBA in Marketing Management from Andhra University, Visakhapatnam. With a strong foundation in structural engineering, material technology, and technical services, Mr. Reddy is dedicated to advancing constructions practices through innovation and expertise. And please welcome me in joining Mr. Koti Reddy for his presentation.
For giving a brief introduction about me. Due to bandwidth, I'll be stopping my video. I'll be presenting and we'll take this forward. Today I'll be covering, hope my screen will be sharing right now.
No, sir, we had only your voice, sir.
Yes, sir. One second, I'm just connecting, sir.
Okay. Yes, sir. Your screen is visible.
Just a moment, sir. Is my voice clear, sir?
Yes, sir. Loud and clear.
Yeah. Okay. Good evening once again for all the audience who have been there in the forum. Now, as it a part of it has already been circulated, I guess we'll be talking on the approach, the sustainable approach, how the construction should be going forward in future, and with the advanced technology that we have in front for the 21st century or even beyond it. So we will be covering a short brief of concrete and some challenges in construction, as well as the new trends that are being developed in construction, as well as in concrete technology, being part of the reputed organization Ultratech Cement Limited, where we strongly work on research and development. As a part of it, we have developed certain solutions going forward for the new trend and technologies in place. Rightly, when we talk about buildings, we have been seeing there are almost tallest buildings in size in terms of maybe it could be in terms of revenue or maybe in terms of the cost, sometimes in terms of taller and faster constructions and all. If you could see from 1930s to the current trend, what we have at the highest is 2000 feet Burj Khalifa or even beyond that. It means nearly about one kilometer. Now the current trend, the current construction which is happening at Saudi Arabia, which is Jeddah Tower, which is about 3000 beyond feet. Just imagine as a concrete designers of anybody by say, we have these composite structures coming up in place. Earlier, because of the limitations to size and shape and moving up to a certain height, so we have been restricted to 1000 feet, 1200 feet, and over an ages when the technologies have been adopted and we have this lifting systems are in place. So we have been now in a right capable position to even build beyond a kilometer size towers and superstructures. That's how if you can imagine buildings that are being super tall, where most of them are found in Asia and Middle East. Out of 100 tallest buildings in the world, 59 are in Asia and 23 are in Middle East, and leaving 18 to the rest of the world. And as I said, like in next 3 to 4 years, we have been expecting this tall Jeddah Tower in Saudi Arabia, which will be surpassing the current height of Burj Khalifa in Dubai, which will be about 2,716 feet. So almost, I mean, the Burj Khalifa is about 2,716 feet tall, whereas now currently we have been expecting that 3,280 feet tall Jada Tower will be coming up. So if you see such a long, tall buildings which are being as a signature for the constructions. So most of them, if you can see the graph here, the blue lines are from 1930s to till 2000, 2010 and all. If you could see the trend of all steel structures, that is what we could not even increase more of. We cannot. We would have taken much more taller buildings, but limitations in lifting systems and the cost and everything. So that was the only criteria where we stuck up in not having a tallest buildings in the older ages. So now when the coming trend, if you have started seeing, the trend has already been kept hitting from 1990s to now current in the trend, we are mostly looking at concrete and composite structures. Concrete basically have a long term in terms of strength, pumpability, affordability, and cost effective. So this has got a favored structural system for tall buildings. That is how, if you see Burj Khalifa, which is of a composite structure or a concrete structure. So in near future, the concrete in India also we have a tallest statue called Statue of Unity, which if you can imagine, the tall of the height of this statue is about 600 feet. It means the concrete that has been produced at ground level should be placed at 600 feet. There should be some engineering properties involved. It cannot be like just as like you mix some ingredients and you call it as a concrete. You call it as a concrete, but there are certain parameters, certain material fundamentals and material science where we need to understand, so that the concrete that should be pumped and placed at certain height should have a performance. Now that is the reason most of the things that all the codes that we talk is only on the strength. But now the near future, the game is only on performance. It means the building that has been constructed should not have any. Sorry, one second. మీటింగ్ లో ఉన్నాను మీటింగ్ లో ఉన్నాను సార్ ఇక్కడ కాన్ఫరెన్స్ అవుతుంది ఫ్రీ ఉందా సార్ ఎవరు లేదు సార్ ఎవరు రాలేదు అనుకుంటా ఇది ఒకటి కాన్ఫరెన్స్ నడుస్తుంది సార్ అయినట్టు చేయండి సారీ గైస్ యా it means like it could be pumpable to any extent with all the current systems that we have with pumping pumps and the other materials that are involved in lifting the concrete, elements that are involved in lifting the concrete. Now it means like what is the performance criteria during the placement and during the at the after the placement also is what the near ball game in concrete technology that we could see. And because without concrete there is no other material for infrastructure to go beyond. And if you see the facts, more than 2 tons per year is produced for every man and human and child on the earth, making it a second only usable material after water. Basically it has been used mostly for housing sector, roads, bridges, utilities, power supplies and industrial buildings. I would say innovation is not so rapid because when we compare with IT systems like mobiles to TVs and other IT systems, so the innovation is not so rapid. That is what it could be prescribed or assumed to be a 21st century material. So it is prescribed to be as a low tech material. So even it is a cost effective also. So in 21st century, we should have a concrete which is more durable, more constructible, more predictable, more green. I'm in a meeting, disturb checking, sir. More predictable, greener, more cost competitive. In such case, even in concrete, we also have a certain challenges with the materials that we have. One is the most major constituent that we material that we use is cement. Even in cement industries that we see also have a challenges, and during the past, present, and future also we have these challenges. India and China will be contributing about 50% of global cement outputs of 2050.
Excuse me, sir. You're muted, sir.
Is it audible
Yes,
now?
sir. Yes, sir. We can hear you.
Earlier it was audible, or now itself it has been muted?
Now itself it has been used, sir. Just now. That's it.
Just now. Okay, sorry. Okay, I'll be keep continuing from here. Yeah, the cement production capacity that we have for 2020 2050 is 750 million tons per annum to meet the demand for the infrastructure that we have in worldwide. Current available limestone reserves are expected to last for about 35 to 40 years, maybe with the current rate of production. There is a huge challenge for cement manufacturing companies also worldwide. One is the carbon footprint. So much of carbon emissions are being emitted to the environment, saying that this will lead to global warming concerns. So even though there is a huge energy required with the production, so much of coal is being burnt, so much of heat is being generated, so much of power is required to produce 1 ton of cement, so much of kilojoules of energy is required. So these are all the concerns, and we have an alternative to cement productions, which where research scholars are still working on this from IITs, NITs, and worldwide. There are many research scholars who have been working. Now, currently, the trend which has been started, even many companies have started adopting this LC3 cement, which is limestone calcinated clay cement, which will even replace the clinker content in the cement manufacturing, where clinker is only the major component in the cement. But now to have a replacement, we use this calcined clay at 30%, and limestone is of 15%, and gypsum is of 5% to produce the cement and all. That is how the LC3 cement has been produced. We also have maybe this would be a dead against to the cement industries. Maybe uh, they may not even implement, or it would be a ball of requirement at the time when we are in short with the limestone reserves. This would be an alkaline activated solution, which as a replacement to limestone and all, we can even produce concrete. It is a no cement concrete, I would say. Coarse aggregate and fine aggregate and fly ash would be the alternative additions for geopolymer concrete. Even in construction, we could see there are certain challenges. The current shape of buildings that we do, and the current form of constructions are limited by forming on site. The rectilinear shape and rectangular shapes are not efficient, high material usage, and even plain assembles are limited to simple I section and T shape sections. So going ahead, we with the current farm cycles, farm work cycle times, and reinforcement laying and tying, reinforcement of requirement of high skilled laborers, we could not even go ahead in building faster and faster constructions or taller constructions. So that's how certain challenges are even in construction. If you could see this slide, the one side is it is full with an auto with full of packs, and the other it is a building. It is even certain challenges for the engineers also, saying like uh, if you see this auto, it is even as per the RTO guidelines, it is like four in all or five in all. But then if you can see this, just imagine of 14 to 15 people, even driver is also sacrificing a seat to accommodate passengers. I think even in Indian rural systems, we still have these autos in place to have a great mobility for the uh, uh, rural transport systems. But here, if a mechanical engineer would have thought, or an automobile engineer would have thought, to give a capacity for four in all or five in all, or beyond that, it cannot. Uh, the engine cannot even accommodate to pull this load, and I would say horsepower. So autos would not have been so popular in India. So that's how it is even taking extra horsepower or something, or even more fuel to even pull this such even loads. Here also in our context, if you're talking about construction, it is even a great challenge to civil engineers who've been working on the foreground to design a durable structures. It is, I know there is a huge gap that is still there. It is that is how in near future we need to bring it down, saying like structural consultants or structural engineers who design any structure sit in a different office as a concrete designers of we like me sit in a different setup of office in a different RMC plant or a ready mix plant or at site. So what happens is there is a huge gap. We don't sit and discuss when we wanted to design any structure. It is only concrete is only thought of for a strength based material. But when we see any structures that are being designed for 100 plus years, or by say Statue of Unity or Delhi Metro, which has been designed, is been designed beyond 100 plus years. It means a concrete that has been casted today should have life for about 120 years, should not have any premature issues. It means like it should be durable and the durability should be more without replacing any with replacing or to have an alternative materials. It should be more sustainable and have a more service life is what the next thought. So making concrete responsible to the requirement, it means like you should have a tailor made installations. Maybe this could be the next future ball game that we could see, because each construction is a different ball game. And ensure, I think all the in India also we have started implementing this performance criteria or defect liability things that are being included in the contractual agreements by any contractor who does any project or a building or any infra project by say. So it means like whatever the construction that is being done by a contractor should have a sole responsibility to certain time of years, so that the structure is being under his custody or in his control, saying that if anything happens he has to repair and rehabilitate and hand over it to the client. So that's how the performance criteria would be coming up in picture, and most of the IS codes are being revised in near future, saying like performance criteria or material science that need to be taught in terms of concrete is also being considered by all the uh, research scholars who have been working on this concrete technologies. When we see as a concrete, when we think, when we wanted to have a concrete for any requirement of construction, apart from these 4 points, one is grade, one is cost of concrete, one is workability, the other is ultimately where we still stand is only on strength. That is what all codes so far are still talking on characteristic strength of concrete or FCK. Beyond this, there is no point that comes into our mind when we talk of concrete. We generally think by mixing of basic ingredients like cement, sand, aggregate, and with some partial addition of admixtures will make the concrete is what we have in our mind. But beyond this, in near future, this would be the thought. It means, for on a classic example to make you understand, you take a star cricketer called Virat Kohli, who has got great fitness, who can stand on the field and have a high energy levels in terms of his fitness. It means his diet, his entire uh, system is something different that a common man have. We can even as a common man, I can eat biryani at midnight also, but Virat Kohli may not, because his system says you should not go with, because he thinks if he is eating biryani in odd times or even taking it in a high diet, so he has to hit a gym for about 3 to 4 hours. Not only that, but his system of health also gets imbalanced. So he's very cautious on taking diets. So that's how on their exercises and everything, there is a huge team involved to monitor these health systems. That's how they keep performing in a big way. Their performance is also we see in their fields when they play for country called India. So now when we are talking about concrete for performance-based design, so methodology is with structural criteria are expressed in terms of achieving performance objective. It is like performance during formation and during the service life. So we have a conventional method. We still, as I said, like we are only talking on strength, where FCK is what the point of discussion which comes. As a concrete by material, it is only looked at, only talked on concrete as a strength. So all structural member capacities, even structural engineers who are still working on the ground are still looking at a steel member to replace all the stabilities or even taking huge loads and all. So in near future, the concrete that is, I think maybe the higher grade of concrete that now we can do with all locally available material is M200, where Ultratech takes this as a pole position in doing with Indian locally available materials with no fancy powders added. It means like it is even replacing the strength of a steel. So that's how even by it is a concrete, it can have a easy to form, easy to place, and speed, long-term durability. Now you can even set the concrete on its demand. Suppose if you wanted to have a concrete, can set in 2 hours, not just like 10 hours is what our code says, but it can set in half an hour, it can set in 1 2 hours. Or if you say you wanted to have an acceleration of setting time, you can add a fantastic different admixtures that are in place right now. Now, if you see the ideal concrete that we talk uh, right now would be, it should flow like a water. It means like it should have a pumpable uh, to any extent. Now, if you're talking and imagining this Statue of Unity, which has been the concrete that has been prepared at zero level, some batching plant at site, and it has been pumped to 600 feet tall, it means it should flow like water. Water means we think more water, we tend to see there is a segregation, there is a bleeding happens, and the concrete is a porous kind. So we generally don't recommend to add more water. But now to have a concrete which can flow on its own, we call it as self-compacting concrete. There are viscosity modifying agents which are being included, immersed in this admixtures now gives a fantastic combination which can flow like a water. So if you can see, concrete we can set the concrete on a demand, like for 2 hours if you wanted to set and get hardened. There are fantastic accelerators which can be used to have a ultimate high strength, rather than waiting for 28 days or 56 days or different criterias of strength criterias. Now you can expect your 28 days result by, say, for an example, M30 grade of concrete, we expect 30 MPa at 28 days, but this 30 MPa can be given in just in 12 hours. It means like half of the day you can get this strength. It means it should gain its strength rapidly. That is now possible. And durability to an infinity, it can be not just by bringing down these cycle time, we are also looking at to enhance the durability to an infinity, is what now we have a big challenge to concrete designers in place. So looking like a new without any maintenance, it means like a structure which has been designed for 100 plus years, the it should remain as same, or it should have a minimum maintenance is what we are thinking. By this, all these properties, you cannot tell the concrete, you cannot say the concrete should be 1 lakh 1 cubic meter, and there is no fun in talking on concrete like this. So it should be a low cost material. So by having a basic combinations of cement, water, aggregates, and little additives like supplementary cementitious materials like microsilica, fly ash, GGBS, or XYZ, and admixtures to have a rescue. This is how the basic that we could see. And there is a big laundry basket of admixtures. I don't touch more on this because this will take out into a different subject. But we have almost beyond this now. If you wanted to avoid corrosion happening in concrete, so we have corrosion inhibitors, we have this air entraining agent, and we have these accelerators, retarders, integral waterproofing admixtures are there. Now we are in a trend where we use the super plasterizers and hyperplasterizers, the huge development which has been happened in admixtures. Olden days, I think some decades back, there are certain constructions which has happened as animal blood is being used in the concrete to have this retarding kinds or accelerating kind of nature. So that's how from there we have started. Now we are in a super plasterizers next generation, where we use this viscosity enhancing additives. And so far, I think near future we may also even have more advances that comes in admixtures which will help the rheology of concrete. So if you could see, there are much more benefits of plasterizers and super plasterizers. It can even have a high flow, reduce the cement content, homogeneous mixes, enhances durability. It can also have a super surface finish, make the concrete greener, low use of OPC and water. Because in concrete, if you think, each and every material is a natural resource, from limestone to the natural aggregates, or I mean coarse aggregate or fine aggregate, and the water that we add. everything is a natural resources. To mitigate and minimize the usage of more of natural resources, we have this as a replacement called supplementary cementitious material or mineral admixtures by say, and chemical admixtures will try to reduce the water content. Water reducers are there, high range water reducers, so that you get great strength and more durability. How this it happens. So if you see this compactability between admixtures and cement is in a simple way to understand. A boy and a girl who wants to get married, we take this both of their horoscopes and go to a pandit, see that if their the stars and everything are in fine, so that they get a better life after getting married. So that's how even we need to understand these admixtures and cement in a big way to understand the compactability, because each admixtures will behave in a different way to each cement, each source of cement. So before we carry out of using these admixtures in concrete, we understand the compactability test by Marshcone test to understand flow, stability, and passing and filling abilities in such a way to enhances compactabilities of the cement and admixtures. So when we see if there is any compactability problem, it could be affected in terms of properties by having more of rapid loss of workability, quick setting, retardation of setting, slow strength gain. That's how the compactability challenges that you could see. And moving on, there are much more factors affecting. You get uh, uh, rate of hydration of cement and water cement ratios of mixes. These would be the factors affecting the compatibilities, and much more. Depends on the climatic conditions also. There could be some challenges that we could see. If you see the modern ordinary Portland cements, even when we are talking, so when we talk to any consultant or if we talk to any construction contractors, they say we need to have more content of cement. I don't know why. So there is no sense of logic in that, saying that when we add more content of cement in any concrete mix, we'll tend to give more. It is assumed or thought in a clear way, saying that more cement, more strength. But absolutely, it is dead against to that. We can even achieve high strength with less addition of cement content in any concrete mix. So now to have high early strength, high heat of hydration, it leads to high heat of hydration. If more high temperature in the concrete will lead to thermal shrinkage and micro cracking in the concrete. That's how when we go for a high thick rafts and all, when we have a mass concreting, we tend to bring down the concrete temperatures in a big way down by reducing 10 to 15 degrees by adding this chilled water, or reducing the cement content to an 50% or replacing that 50% with mineral admixtures like GGBS, fly ash, and other additives to gain the strength and all. But then without that, by adding all this, you will tend to see there is a huge drop of the shrinkage cracks coming down, and micro cracking of concrete doesn't happen. So that durability is been increased by looking at all these properties. That is what when we design any concrete, we need to understand all these material science in a big way. So one alternative is we have this blended cements like which is already been produced at plant, or where we call it as Portland Pozzolana cement as a PPC, where the fly ash is being induced at the time of production itself. And we also have this PSC cements, Portland slag cement, where we use uh, GGBS as an alternative for this cement, and which has been produced at site and been produced at factories like cement factories, and it has been transported to sites for different usage purpose. So now we when we use this supplementary materials or blended additives, so they will have a slow reaction where we will find to see the heat of hydration is very less, and micro cracking is considerably reduced and improved on soundness and impermeability of cement paste. So that's how we could see a sustainable or durable options that keep coming up when we use this blended concretes or blended cements in our construction. So we could see better reduction in bleeding. Mix is going to look like kozu, like our curd rice that we see. So much of improvement in workabilities. That's how this supplementary cementitious material keep helping us. When we see this hydration, how this happens when we add water to cement or to any concrete, we have this reaction which forms CHS gel is more like a gel, So calcium hydroxide of 30% and plus heat and this, we will have a double reaction in terms to make you understand. With a OPC grade of cement or concrete, you will have the only single action hydration. So it is like primary, when you calcium hydroxide plus CO2 plus humidity, it would degrade and there would be only single action of hydration which happens. When you see this blended cement will have a double action hydration where the leftover calcium hydroxide will also react with this reactive silica, so that to have a denser impervious concrete. It means like all the packing system is being done in such a way. To make you understand, here in this image, the left side image is something like PC stands for Portland cement, where you find to see the voids are still in place. When you see this on the right side, you have this SCM as a supplementary cementitious material as an additives of, as we call it, as a mineral admixtures, as a filler material. Not only as a filler material, but then these are like a reactive silica where it can have a double or a secondary reaction where it forms a dense and impervious concrete. So we could even see there is a huge gap up of strength developed in the blended concretes. Maybe the initial strengths would be slightly lesser in terms of higher OPC grades, but at the time of 28 days or even beyond 28 days, there are certain examples that we could see the strength is kept on gaining till up to 90 days or even 1 year also. So that's how it is very sensible to go with a blended concrete construction, which will be not only helping you to enhance your strength, durability, and other aspects as an eco-friendly or a green concrete, we would say. When we see the sources of natural aggregates are also rapidly depleting and non-availability of incautious aggregates, we still have a great dilemma on this recycled use of recycled aggregates. Now, many research people are working on this to replace a natural aggregates. When we demolish any building or any structure, we are not even a percentage is being used from this construction, the concrete debris, the construction debris, I would say CMD waste. So nothing is being used in the concrete, the fresh concrete. So now many people, I have done my graduation project on this recycled aggregates where we wanted to replace to 10, 15, 20% from the natural aggregates that we use in terms of 20 or 10 or different size of an aggregate, coarse aggregates that we use. So, so much scope is still is there with us to have a better durable concrete structures with sustainability in front. So when we see certain articles of newspaper clippings which have been started, implemented, many states have been started implementing it. We still have a big challenge with the government bodies, like governing bodies who take the decision to implement all these codes and the permissions and approvals for this. So now, if you see, now we are in 2025. This now current development that we could see in concrete, uh, this has the current trend that we see in concrete right now in India is already been adopted in developed countries some three to 4 decades back. So we are still lagging in terms of adopting systems. The self-compacting concrete that we talk in next slides are developed by Japan in 2000s itself. It means like 20-25 years back. But then still in recent times, like before 5 years, I think it has been incorporated in our IS codes of 10262 as a criteria. So that's how the huge gap that is coming up from the government side also. Even when we have a shortage for this natural sand, when the construction industry sector itself faces a delay in the handovering projects, where we wanted to have a replacement of this M sand is now gradually gaining popularity. Many governments are giving subsidies on this loan interest, uh, and due to non-availability in metro cities like Hyderabad, Delhi, Chennai, Bangalore, and all, we don't have these natural resources because of the tremendous construction activity that happens in these metropolitan cities. We have to go ahead using this manufactured sand. When we are talking about durability in a big shape, to understand, we need to from the approach to the processing end, then only we can try to absorb or adopt and see the durability aspects coming up, right from environmental impact and design aspects and performance criteria at the time of approach or during the time of designing itself. It should be taken at the time of processing, when we need to understand material characteristics. Mix proportioning, placing, compaction, and curing is what one more criteria that we need to do. it means like performance of a concrete comes during the placing, during the forming and all. Then only we can try to see the durability aspects where a structure can show you in a longer run. So what influences for the durability of concrete? It means like the less durable when they have a physically chemically compressed. So cracking due to shrinkage can also allow reactive gases and liquids to enter into the concrete, because chemical because any structure which is exposed to environment will have a different changes in climate, and also allows such a certain unwanted gases and gets, if there is any steel member or reinforcement inside the concrete, it gets start hitting that and the corrosion starts there. So that's how it weakens the structure in a big way. So we could see certain structures which are being built in the coastal areas will have much more challenge over to this. So that is how there are even certain challenges like alkali silica reaction, opening up cracks and allowing other agents to enter into the concrete and form the chloride or sulfide, forming on the steel bars and try to get into the corrosion rate in a higher way. So that's how this will influence the durability aspects in big way. So when we wanted to have a longevity of structures, which will help you to contribute astronomically to the growth of country, we need to have a special and durable concretes with a new trend that we wanted to adopt, which is called special concretes. So we cannot go with the regular conventional way of approach because the systems are working in a different way, and now we have this in IT systems we call this artificial intelligence. Maybe I think we can also monitor the strength health of a structure by different equipments that keep coming up. That would be the new trend, I would say. Now we also have certain challenges in running short of time. I will try to bring down in a much more in this future slides that we see. Not just adding as a minimizing the dosage of cement, we also use supplementary blended cement, as we have spoke already. We use these fibers in terms to have a great resistance to shrinkage cracks in the fresh stage. We also use these conventional materials like uh, supplementary cementitious materials and replacement to recycled aggregates or some more. So that's how it is. No cement concrete is what maybe a near future a game changer to the construction. Without a limestone or a cement that has been used in concrete, we can also produce the concretes in such a way. Maybe that would be the real trend, changing the. And when you have this congestion in the reinforcement with the two perpendicular walls, can we have this a conventional concrete getting here when when we don't have any scope to put our vibrating needle to compact? So this would be a big challenge when we see structures will have a honeycombing nature or porosity where it will degrade the structure integrity or in a big way. So if this is a congestion in the beam and column joint, so that would be a big danger to the structure. So we have to have a concrete called self-compacting concrete, which doesn't segregate, have a segregation resistance from the mortar and viscosity, not aggregate grading out. This is called concrete which flows on its own. The cost may be initially high, but now with the current development that we have in the admixtures, as I said, like viscosity modifying agents, which are combinedly given in the admixture itself, so that it will help you to get a more olden days. I mean, now maybe in our colleges and uh, in our laboratories also we have the slump cone, but now more the slump beyond 200, we say this is a collapsed concrete. But now when we are talking about this self-compacting concrete, the flow of this, we don't talk slump, we don't only talk on flow. The flow of this concrete is about 500 to 600 mm. So it means like it has to be tested on flow table. It should have a high control for this flowing and filling abilities and all. And the mix also is something a different secret. I would say it is a real miracle to an engineering fraternity, saying that if you wanted to send a concrete to any nook and corner of any different shape, architectural shape, with this concrete you can try to achieve. This is how the secret of self-compacting concrete, more of fines and less of coarse, coarse aggregates, so that you get using this viscosity modifying agents or lower water content by using high range water reducers, you can achieve this self-compacting properties inside the within the concrete, that you can leave the concrete which flows on its own. When we are talking about concrete in a big way, we also see that concrete has got a beautiful nature to crack. Cracking of concrete is an inevitable phenomenon. We cannot even stop it. We have to control concrete to not to crack by having some certain remedies and systems in place. But now we have a concrete called self-healing concrete, where concrete can heal on its own. This is a cement-based material that repairs themselves after the material or a structure gets damaged due to sort of deterioration mechanism. It means like all the structural cracks may not be addressed, any micro cracking or macro cracking that can be uh, healed on its own, because it is just like a bacteria added into the concrete during the time of batching. It will have a high survival rate, even though if any structure will have certain cracking of micro cracking beyond 15 years, 20 years also, it will if any presence of humidity or moisture, this will get activated and it forms a healing nature. It is just like uh, an alkali bacteria grow active, then they make limestone out of calcium lactate and forms the healing. This is how make you to understand. There is a pictorial to make you understand if there is any water or a moisture presence, and it gets activated and the healing process happens. It doesn't happen overnight. It takes about 50 days, 60 days, or even 100 days to heal the size of the crack that you can see. And if you can see this microscopic images, there is a crack in A figure, and slowly it has been healed out, and you could see the bacterial specimen after healing. So you could see as if there is no crack on it. So it doesn't happen overnight. It takes some time to do it. And we also have we see that 1 cubic meter of concrete requires 3 cubic meter of water, because this is also a natural resource. And this we see when I was working at Bangalore. Currently, there is a huge shortfall of water availability for domestic needs during the summer time, or even some areas in Bangalore doesn't get water every day. They get once in 3 days or once in a week. So such a shortage of water, and you could see the density of population getting increased in my metropolitan cities, and everybody wants every government is focusing on urbanization and infrastructure. Without concrete, there is no other activity that happens. Every human needs a shelter, a place to live. So in such case, concrete is seeing a big challenge for the curing also. If a concrete that is being produced is of any grade, but it should be cured. So with the depleting sources of good quality water, we are lacking the accessibility of structure, because limited water cement ratio is used in for high strength and high performance concrete. The continuous curing to be given in place. But now, when we have a shortage of water, then where is the option to go ahead with this? So we have this system in called self-curing, using pre-soaked lightweight aggregates, or even after completing the uh, concrete and deshuttering it, we apply uh, this curing compound onto the surface soon after deshuttering it, so that there won't be any moisture loss. Whatever the water that has been added in the concrete will it means like you wear a sweater in the summer, what you get sweat, lot of sweat. It means water is coming from body. The similar way it is also, whatever the water that has been added in the mix will help you to get, we will be used for curing purpose. That's how the self-curing compounds that are being in place right now. Now we are doing it on an external application for the concrete surfaces. Now some lot of research is happening where you can add this pre-soaked lightweight aggregates, or there is an additive that is being added at the time of batching, so that you just lay the concrete and leave it. It takes the entire activity of curing that required, and there won't be any. There will be a slight drop of strength, but then this is helping us to save some water demand that we have in construction. The demand that we where water is much more required for curing. So this will replace that, a partial replacement of the curing practices that we see. It is just like a diaper where water, it seems dry when there is no moisture or water in it. When a kid have more of urinal, so you could see it gets bulge. So that's how the curing of I mean, just to make you understand. So one more development that we could see we can draw to any extent with a pen or a paper that we have, but then concrete can be bendable to any shape and size, where we call now currently the trend within IT systems, and maybe the context of entire game is only on this 3D printing. But I just wanted to bring and put some thought of concrete, how it is going to change in near future with, in addition to this, because 3D printing has got limitations to its structural abilities, and this is only restricted to have an architectural shape. Uh, even now, when we are using these systems, concrete, just like formed in different layers, passes from nozzle to retain its shape. That's how there is a mixing uh, pump, which where we feed all the materials, and with bit of an aeration, it has been passes through the pipe, and there is a robotic mission which is connected with a nozzle, and there are certain polymers and binders like cement and other additives which help you to get passed through by this nozzle and forms a shape. If you wanted to build any shape, it forms in layers rather than doing it in. This is how the system works. It printing refers to the process used in a synthesized 3D model in a successive layer of material to create an object, for example any concrete wall. So it should be there are certain polymers that have been added. The only concrete now, if you could see, you can bring any shape in a different layers. So that's how the 3D printing works. But there is a huge disadvantages still. Things are working in a different line, so beyond that we can even we cannot go. So that's how it has got some few disadvantages in the cost and the strength parameters, because there is no structural steel members that are being inserted. It is only working on this concrete as a strength. So if you could see the engineering of a material develop with the technology, right and express with the concrete is what we say. If you wanted to have different shape, different size, so this 3D printing would be a near ball game for the construction industry that we could see. Many colleges, many research institutions, and many startups have been started doing this 3D printing in a big shape for the architectural shape and size. But slowly, I think this would be an adoptable case in the near future to come, so that it would be used for certain applications, not just for tall buildings and some more. So this has got a much more limitations, and so much of research is still happening. So with this, I think I can try to conclude my remarks, where the construction industry has a huge role to play in the sustainable development, not just as a concrete, but we have a lot more technologies coming up. We have seen so much of changes that have been happening from structures which have been tall and having a great performance because of the composite nature, where concrete and steel has been uh, adopted. And durability is one of the most important pillars of sustainable, because at the time of designing any concrete, you should have a systematic support from QA and QC. Procedures have to be taken care, so that you can tend to see the sustainable concretes that come. And maybe if you wanted to see a lot more changes, like artificial intelligence helping you to get this mixed designs. If you feed certain raw data, so that can help you whether to choose a grade of concrete or to have additives in a different way. So that's how I think maybe in near future it could be a ball game. It would be a change that would be coming up in recent times. I think this is my at the end to my presentation. With your cooperation and valuable time, I would like to thank you for giving me this opportunity to showcase my knowledge on this through a platform, so that as a civil engineers that who have been taking up a role to build the nation building, or a country or ourselves or a company or a country, we need to be proud to saying that we need to build structures for a longevity and have more uh, I would say sustainable approach that we can see. With this, thank you. I would like to thank the management of Paris College for giving me this opportunity to showcase uh, my skills on this, and I would like to unfair. I think one sec. Hello.
Yes. Shall we go for the Q&A session, sir?
Yes, sir, please. I think
Yeah.
PPT has entirely run very well, I guess, if I'm not wrong.
Yes, sir. It's going
Yes,
well. It's going well.
yes. Thank you, sir. Thank you. Yes.
I request participants. The Q&A session is open for you all. Please ask any queries you have, or you can post on the. And you are all are unmuted. If you have any queries, you can also post in the chat box also. Thank you.
Sir, good evening, sir. I'm Dr. J.T. Naidu.
Good
My
evening, sir.
question is, yeah, concreting, after casting concrete, the cubes, if you keep continuously for 7 days or 28 days in water tank,
Yeah.
is there is any effect of strength?
The temperature should be as per our climatic condition. I mean, room temperature is what we generally say 27 degrees plus or minus is what we need to maintain in the curing tank also. Maybe in site conditions it is not possible when we are having this as a control system in QA labs and QC labs that we in the projects or anywhere during our phase. So this maintaining temperatures in the curing tank will not have any fluctuations in the strength, whereas if you are putting these cubes in elsewhere in some tank and it is exposed to environment, then there would be a slight change in the strength up and downs that may happen, sir. The fluctuation may be here and there.
The
So
formation of CSS gel is same for if you keep outside and curing with water and continuously keep in tank is same, sir. Is the formation is gel formation is any difference is there?
absolutely, sir. That is what when we expose this curing situation to environment, maybe you see we will have a different change in temperatures. Now, in late nights, we see there is a temperature drop. Maybe in winters it would be somewhere about 15 degrees, 13 degrees, and even less than that in certain locations. So when you see in the daytime, it will go up to 35, 40, and all these fluctuations will try to have a difference in the strength and the attringent formations and CHS gel. The reaction hydration phase also will try to see. That is how you will have a change in strength. So one cube gets higher strength, one cube gets lower strength. It also depends on the person who has started. I mean, the way that has been casted is also a major factor. But that is what in a control system, when we see any third-party laboratories or laboratories, they will have a complete shed for their
Okay.
curing tank, or they also put this thermometer and keep monitoring the water temperature.
Yes,
So
yes.
that is how we could see there won't be any change. So that is how it should be. At time of casting, whatever the care that we take, the curing also should happen. But then to see the exact result. But if for any structure, no, that is what we say tend to do curing in a ponding way. I mean,
Yeah.
for any slab that you see, roof slab or somehow, earlier, I would say maybe my house was being constructed 15, 20 years back by my father. At that moment, we have cured it for 20 plus days.
Yeah. Yeah. That
We
time.
used to
Yeah.
top up this curing, but now the rate of construction has come very fast. Like nobody's putting up shutterings for about 20 days or the farm work for 20, 25 days. They have brought out to 1 week, 10 days, or even 15 days, between 10 to 15 days. It means like the construction industry is working so fast. But for that reason, now adapting to go with high grade of concretes and use of more material consumption is happening. So to avoid this loss of, suppose if the structure is been designed for M30 grade, they are taking one grade higher, like M35, to compensate this risk.
Sir.
So that's how it is happening, sir. Yes.
Yeah, regarding self-healing concrete, what is the bacteria you told, sir? What is the gel? Bacteria in form of how will do that self-healing in a laboratory experiment?
Sir,
What
it
is the
is not just as a bacteria, but I made you to make understand is it has got as a bacteria, but it is a crystalline polymer, sir, basically, which is induced into the concrete at the time of batching, which acts like a bacteria, a dead bacteria, I would say, make you to understand, but it is not actually a bacteria. It works with calcium hydroxide and forms it works with limestone and leftover calcium hydroxide, whatever it has been there. So it forms a precipitate and heals
Good.
the cracking. So it takes about 40-50 days or even beyond that with the dosage that we have. So it has got a high survival rate. All these crystallines, no, which doesn't allow to, they forms a crystallines when there is a presence of moisture and water, or I would say. So this will block the cracks. Doesn't
Okay.
allow any water penetrating inside. So that's how the crystallines works.
Oh,
Sir,
no, sir. No,
shall
sir.
you
Hello,
please
hello.
share your email ID so that we have some doubts. We'll clarify with you. Mail.
Definitely, sir. Sure. I
Hello,
think
sir.
I'll.
Sir,
Thank
there
you
is
very
a
much.
small query, sir.
Yeah,
Self-healing concrete is a bacterial concrete. We have to be produce the bacteria in the laboratories. We have to be add in the cement content, and we can prepare this one. Self-healing concrete has the Bacilla G30, G300 is the one bacteria is there, sir.
sir. Actually, my microbiology lab in the
Yes,
microbiology lab,
yes,
they are
yes, yes.
producing one bacteria.
Yes, that is Bacillus, sir. Bacillus.
Yeah, yeah.
You can
Let's.
produce wherever the agriculture universities are there, some JNU Hyderabad, some chemical, that is chemistry laboratory, they are preparing, sir. But it's
Yes,
a present, it's a costlier because the production of basket is not at all easy. We have to be separate from that is called screening. That's a very difficult, but it's there. Bacteria concrete means you have to be induce the bacteria inside the cement. First of all, you have to be add and you can taken into the mortar.
that is the one process of experiment they're conducting, whether the normal concrete by adding this gel, any improvement concrete they are doing, sir.
Definitely, definitely,
Yeah.
definitely, sir.
But,
Especially
but
concrete compressive strength and flexible strength and friction strength will be enhanced
yeah,
nearly 25 to 30%, sir.
sir.
But presently, the bacterial concrete we are using for the only for heritage constructions only, sir. Practically, it is not possible for the high
The
volume concrete.
controlling systems are very high, sir. So we need to
Yes,
control that in a big way. Now, in
BTech.
our crystalline case, is what generally we tend to follow, sir, because it is a cost effective. If you say all these crystalline polymers, no, will try to have at a rate of per kg 200, 300 rupees and all. So this would be economical in by chance. If you add this to a concrete, also may not have a huge cost. It would be somewhere about 1,000 rupees, 1,000 bucks addition to your concrete general rate. So
Sir.
so these crystalline polymers have been now used as a replacement to these bacterials and all. So this also works on a similar line where we are using it for water tightness and all. We have a product as a solution saying like Ultratech and Aquasil. So this concrete will resist the water coming inside, because this, and at times when there is a moisture present, this forms the blockage. They
Sir.
form the crystals and
right.
which are insoluble in nature. So this,
Okay.
that's how the system I said like self healing.
Okay. Okay.
Yeah,
My BTech students are doing this project. They're having some doubts. That's why I'm asking your mail so
definitely,
that
sir.
yeah,
Yeah,
please.
I'll share it here, sir, and the chat box so that
Yeah,
uh,
I will take the chart box, sir. Okay. Thank
yes,
you very
yes,
much,
yes.
sir.
Thank you so
Thank you.
much, sir. Yeah. Any questions, sir? Or
I hope your questions from the participants now. Thank you, Mr. Khanna, for the valuable session. You have been
yes, sir.
great patience, and thank you for giving us the more insights about the concrete industry and cement industry. Definitely, we'll be very proud to have you in the meeting. Thank you so much for joining us, sir. And
Thank you
you'll
so
be
much,
always
sir.
remembered. Thank you so much, sir.
Thank you once again, sir, for giving us this
Thank you.
opportunity as a platform from you.
Yes. On behalf of Business of Technology and Sciences and Civil Department, we thank you all.
Thank you, sir. Thank you, Mr. Koti, for giving this opportunity once again. Yes. Should I quit, sir?
Yes, sir. Thank you. Thank you, sir.
Thank you. Yeah.
Dear participants, The feedback form will be only open for the mail IDs which you have registered during the registration process. Kindly check whether you have been doing with the same mail ID or not.
Sir, I have registered through mail ID only, but still it is asking the access.
Sorry, may I know your name, sir?
Pratikul.
Pratik Kulkarni. Could you drop your mail ID in the chat box if possible, sir?
Yes,
Let
yes,
me
sir.